Welcome to section 3.3. Today's video we are going to be solving systems of linear inequalities by graphing. So the very first video of the chapter we solved linear equations by graphing. So we graphed two lines and found where they intersect. Today we're going to be looking at linear inequalities. If you remember the linear inequalities from last chapter, that's when we had the shading. So there's going to be some shading involved. So let's just jump right into example number 1. You're going to see that we have two inequalities that we need to graph. So please make sure you grab a straight edge if you don't have one. This first one, I'm going to graph it in blue. This is slope-intercept form. So I know I have an intercept of -5. And my slope is -3/4. So I'm going to go up 3 over 4. Negative slope means our line should be falling. Okay, now this is not a line, it's an inequality, so we need to be careful here. There's no equal sign, which means we need to have a dashed line. So we should have a dashed line. And then there's going to be shading. Now, if you remember with the shading, we're going to plug in a test point. I like to use 0. 0, 0, that is the origin. So we get 0 is less than -3/4 times 0 minus 5. So that's just 0. 0 is less than -5. Is that true? No, it's not. If we think of a number line, -5 is to the left of 0. -5 is small. What that tells us is we do not want to shade at 0. So we don't want to shade it where 0, 0 is. We're going to shade over here. Okay, on to the next one. I'm going to do this one in green. This is standard form, so for this one, I'm going to make the XY table. If I plug in a 0 for x, I get 0 plus 6y is less than or equal to 12, which gives me a y of 2. If I plug in a 0 for y, I get -2x plus 0 is less than or equal to 12, so my x is -6. So I'm going to plot those 2 points then, 0, 2. And -6, 0. In this case, we have an equal sign in our inequality, so that means we're going to have a solid line. Again, putting 0, 0 in, I get 0 plus 0 is less than or equal to 12, which is true. So for this one, we want to shade towards 0, 0. Now, we are looking for where those shadings overlap, and we need to make that clear. So I'm going to do the overlap in red. So red is our final answer. Now, what does that mean? What those red points mean are any points in that red region are going to satisfy both inequalities. So any points in the red region will satisfy both of these inequalities at the same time. If I pick a point over here, it'll satisfy the green inequality but not the blue one. If I pick a point over here, it'll satisfy the blue but not the green. The red area satisfies both inequalities at the same time. Let's do one more example together, and then you're going to do one on your own. So we're going to look at example number 2. Again, I'm going to do these in 2 different colors. Top one is going to be in blue, bottom one is going to be in green. I'm going to start with that green one. Y is greater than -1. So this is either a horizontal or a vertical line. It needs to go through the y-axis though. So the y-axis is the up-down, as we can see. Y is -1 is here. No equal sign, so we should have a dashed line. Okay, plug in 0. We get 0 is greater than -1, which is true. Again, think of a number line. So we are shading towards 0, 0, which is up here. Now let's go on to the blue. This is point slope form. Our point in this case is here and here. Remember to switch the signs. So this is +4 and +5. and our slope is -2. So +4, +5 is right here, slope of -2. In this case, we're going to have a solid line because there is an equal sign. So don't forget that solid and dashed. Okay, this one's going to be a little bit trickier to check. We're going to plug in 0, 0. So we get 0 minus 5 is less than or equal to -2 times 0 minus 4. Left side, this is -5. Right side, this is -2 times -4, which is 8. So that's good. That means we shade towards 0, 0. So that's right here. Again, we are interested in where these overlap. Where they overlap. The overlap is right here. So that red region is all the points that satisfy both inequalities at the same time. All the points that satisfy both inequalities at the same time. So right now, what I would like you to do is try example 3. Pause the video and do example 3 on your own, please. Okay, I hope you've had a chance to try example 3 and that you're feeling confident. When you're ready, please flip to the next page and we are going to do example 4 together. Example 4. You are taking a test in which items of type A are worth 10 points and items of type B are worth 15 points. It takes 3 minutes for each item of type A and 6 minutes for each item of type B. Total time allowed is 60 minutes and you may not answer more than 16 questions. How many questions can you answer? Okay, so this kind of problem is called linear programming. It's a real-life scenario where you have some things that are constraining you. So in this case, we only have a certain amount of time that we can spend and we can only answer a certain amount of questions. And so we want to know how many questions can we answer, keeping in mind that we only have 60 minutes and we can't answer more than 16 questions. So defining our variables. Like before, like the word problems we did when we were practicing substitution and elimination, to define our variables, we need to look at the question that's being asked. And that'll give us a clue as to what our variables should be. So we are asked, how many questions can we answer? Now, in this case, there's questions of type A and questions of type B. So I'm going to say A is the number of questions of type A that I can answer. B then is the number of questions of type B that I can answer. Okay, so now we need to write a system of linear inequalities that represent the constraints of the problem. Constraints, it just means the various things holding us back. So why can't we just answer all the questions? Well, we only have a certain amount of time and we can only answer up to 16 questions. So in this case, the first one is time. And then the second one is we can only do 16 questions. Okay, so if we can only do 16 questions, we're going to do so many A questions and so many B questions. If I do A questions and I also do B questions, the number together of questions that I answer has to be less than or equal to 16. So this is the constraint for the number of questions. Now, I also know that I can only use 60 minutes. It takes me 3 minutes for each item of type A. So each item of type A takes me 3 minutes. So 3A will be all of the time that it takes me on question A. Those question B questions take 6 minutes. So 6B is all the amount of time that I'm spending on those B questions. When I add it together, my total time has to be less than or equal to 60 minutes. So the most amount of time that I can spend is 60 minutes. Now, is there any other information that we haven't used? Yes, the point values. In this case, that is extra information. Now, we want a high number of points, but the points are not limiting us. So the only limitations we have are that we have 60 minutes and 16 questions. So let's go down and see what's next. In part C, you are going to graph those two inequalities. And we need to choose a scale and label the axes. So what I'm going to do is I'm going to bring these two down. Okay, so that is what I need to graph. I'm going to call my x-axis A. So instead of using A and B, we could have used X and Y, but I'm going to use A and B. So A is going to be on the x-axis, B is going to be on the Y. And again, these mean the number of type A questions. And this axis is the number of type B questions that I answer, of course. Now, I do need to graph these two inequalities. The first one I'm going to graph in green. Second one I'm going to graph in red. Okay, so if I look at this green one, this is in standard form, so I'm going to need to make my chart. Normally I would put X and Y. In this case I have A and B though. So if I plug in a 0 for A, I get 16 for B. And if I plug in a 0 for B, I get 16 for A. Now I'm going to graph the second one or make my chart. If I plug a 0 in for A, I get 6B equals 60, which will mean that B is 10. If I plug a 0 in for B, I get 3A equals 60, so A is going to be 20 then. Again, we could have used X and Y, so if this is confusing you, in your classwork use X and Y. You don't have to use A and B, you can use X and Y. Okay, so in this case now I have to graph. I need to figure out what I'm going to scale by. So I will tell you that there are 20 boxes. On the A-axis, my A gets to 16 and it gets to 20. So if I count by ones, I can in fact make it to 20. Likewise, going up on the B-axis, we get to 20 as well. I have to get to 16 and 10, which is possible. So here's what I mean by that. If I go to graph this, my green inequality, I'm going to start with this first point, 0, 16. So that means 0 on the A, but go up 16 on the B axis. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then likewise, I need to do the same thing on A. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so then of course I'm going to connect these. In this case, I have an equal sign, which means it's going to be a solid line. It's an inequality, so I do need to shade. If I plug in 0, I get 0 plus 0 is less than or equal to 16, which is true. Okay, now if I graph my red, my first point is 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 20, 0 is all the way over here. So I'm going to connect those. Again, you should be using a straight edge. If I plug in 0 to that inequality, I get 0 plus 0 is less than or equal to 60, which is true. So that is here. And then of course remember that we are most interested in where they both intersect, which would be this region right here. So that is our region where both inequalities are true at the same time. Okay, in part D, assuming all of your answers are correct, State 3 combinations of A and B questions that would comply with the above constraints. So we talked about in the earlier problems, any points that fall in that region, in this case the black one, are going to work. So if I pick this point, for example, that will work. That is 3 type A questions and 1 of type B. If I choose this point right here, this point's coordinates are 4, 3. So that'll be 4 type A and 3 type B. And then what I can also pick, this one right here, of course. So 0 type A and 0 type B. So what all these points mean, these are the points that are possible, or the combinations that are possible, given my time limit of 60 minutes and my question limit of 16 questions. So I know this one was tricky, but we will definitely do more like this one. So it's okay if this one was hard for you. When you come to class over the next few days, we will do a few more of these. Please make sure that you have done example 3, the you try it problem, before you turn these notes in. If you have any questions, please write them down and I will make sure to answer them in class.